Dear friends, let us understand what we understand by pipelining. Pipelining plays a very important parameter in terms of computing because it consists of the different data streams. See, these data streams are being interconnected with each other, and the output of one data stream becomes the input of the other data stream. So these elements work in the form of pipelining. So let us go ahead and look into it. So what does it looks like? A pipelining is a series of stages where some work is done parallelly. One stage is being connected to the next stage to form a particular pipeline. And these pipelining, these set of instructions are being executed simultaneously. That they enter at one stage and exit at the other, and it becomes the input to the second stage. And these processes execute simultaneously. So this is the process of pipelining of the instruction, the flow of instruction which takes place. So entry at one point, exit at the other point. Now, what are the different pipelining processes? First of all, the pipelining processes are being divided into the five types. First is called as you will fetch the instruction from the memory. Now, why memory? Because the instructions are being stored in the memory, and you'll be using address bus and data bus to fetch the instruction and to get the address of those instructions. After fetching the instruction from the memory, you will decode the instruction. Now, decoding means you will be executing it in the form of the machine language. The machine language is in the form of zeros and ones so that the computer can understand it and give you the desired output and result. And then you will be executing those instructions to get the desired output and result. Read memory to get the input and write back the result. So what will you do after executing? You will read, you will execute, and again you will go and store the data into the memory. So what have you done? You have pushed and popped the instruction. You pushing means you have put the data into the memory. Pop means you have taken out of the data from the memory which needs to be executed. Then you have executed simultaneously, and again you have pushed the data into the memory. This is called as your pipelining processor and how they simultaneously work. So what are the different instructions in case of a pipeline? The instruction execution process lends to itself naturally over pipeline. Now, overlapping of the subtask of instruction fetch, decode, and execute. Now, fetching of instruction is called as FI, DI is called as decode instruction, calculate operands, CO, fetch operands, FO, execute instructions is called as EI, and write result is called as WR. So, overlapping of these operations take place simultaneously. Now, let us understand the 6 stages what we have discussed. You fetch the instruction, then you decode the instruction in this flow diagram. After decoding it, you calculate the operand. Now, you calculate the operand because you will find whether it is in the proper format or not. If it is in an unconditional branch, then you will go with the flow of yes, and you will update your computer and empty the pipeline, and again it will go to the fetching of the instruction. Now, if we go in the flow of a no diagram, it will again fetch the operands, execute the instruction, write the operands, and see whether some interrupt is there or not. Now, interrupt are the set of errors which come in a program abruptly. So if there is some unexpected error that is coming into the program, there is a possibility that some interrupt will happen. And if there is an interrupt, it will go to update PC, and from there again it will empty the pipe, and it will again go to fetching of the instruction. If it is no, then again it will, if it is no, there is no interrupt into the program, again the instruction gets completed, and again it will go to the top to fetch the instruction, decode, and the same operation gets repeated simultaneously in the form of pipeline. So when you are executing any instruction, you should also be aware of the different terms, like different forms, like the interrupts which are coming into the picture. So these interrupts play a very, very important role, because if there is some unwanted error that comes in, so the interrupt informs you about the unwanted error that are coming in into the program. Now, when you look at the timing diagram for operation pipeline of operation, so here you have 1 to 9 is the instruction which is being listed onto the X line, and you have time simultaneously. So when you look at instruction 1, now after the on the time after 1, the instruction 2 gets executed on 2, the instruction 3 gets executed on 3, 4, and up to 9. So you have instruction fetch, decode, and perform the same operation. FI, DI, CO, FO, EI, and WO. It goes on up to the instruction 9. Now, this is important because simultaneous execution of the instructions takes place simultaneously, and all the instructions are being executed parallelly and into the pipelining phase. Now, what are the advantages of pipelining? It makes the efficient use of the resources. So if the resources are not used, they are being let free. Quicker time access of execution of large number of instructions, and parallelism is invisible to the programmer because all the instructions are getting executed parallelly, and the programmers are mainly concerned with the output, and simultaneously the output should be in a faster way. So parallelism is not visible to the programmer. Now, what do you understand by the pipeline hazards? What do you understand by hazards? Hazards are some sort of obstacle. So there are different types of hazards. One is called as your structural hazard, one is called as data hazard, one is called as your control hazard. The structural hazard attempt to use the same resource by different instructions at the same time. Now, what happens if the same type of instructions are being executed? So they are trying to use the same resource. The same resource can be either the address field or the data field, and they are trying to execute the same instruction simultaneously. But this becomes a part of your structural hazard. Then you have a data hazard. Attempt to use data before it is ready. What happens? Now, suppose that if you have fetched the instruction, but your instruction is not being decoded properly. So what happens? Has the instruction got converted into the machine language? The answer is no. But still, if you're trying to execute those instructions, it becomes a part of your data hazard. And instruction source operands are produced by prior instruction still in the pipeline. Then you have control hazard. Now, in case of control hazard, you're trying to attempt to make a decision about program control flow before the condition has been evaluated and the new target address has been calculated. For example, branch instruction. Now, in such cases, you should remember that you are executing the control unit. The control unit is a combination of ALU and the different buses and the different registers which are being interconnected with each other. Now, when you're performing any operation on the instruction, if these three components, that is the system bus, address bus, and the control bus and data bus, are not in synchronization with any of the parameter, like it may be a parameter, but they are not synchronized with ALU, they are not synchronized with the CPU, they are not synchronized with the registers for push and pop operation, then definitely there is a possibility that the control hazards will take place. You will be executing the instruction, but the instructions, you will be getting the proper output, but your instructions won't be getting same. So these are some sort of hazards that take place in case of your control hazards. The example can be a branch instructions which are getting. So how can you resolve these hazards which are taking place? Now, it is the responsibility of the pipeline control, the pipeline, for detection of the hazard and also to take the necessary action that are responsible for the hazard. Now, what are necessary actions? For example, if you're executing a particular instruction and there is a new instruction coming in, so it is the work of a pipeline to check the new instruction which is coming in and simultaneously give the signal like busy or wait. If the processors are busy in performing a read operation or a write operation, the signal should be busy, or it should give the signal as wait for the other instructions to get executed. So if pipeline processors are keeping in mind the structural hazards, what are the possibility of structural hazard, data hazards, and control hazards, these hazards can be avoided by using a proper pipeline architecture simultaneously.